progress.
I can't hear you.
Can you hear me now, Jordan?
Yes.
Okay, my earphones weren't plugged in.
Oh.
Good enough. I can always depend on you to be here. Any problem with the lab so far?
No.
The one you have to do on Thursday is a bit tricky. It's a bit. I tried to do it yesterday. Actually, I was doing it yesterday. It's very, very frustrating. You have to look at the instructions. Like, for example, they tell you to move the one cup on top of the other cup. Then it's kind of like I wasn't paying attention. I'm trying to move these two cups onto the stirring device. It's not, it doesn't work. Then finally, about 5 minutes later, I look and said, oh, you have to add the stir bar and the lid to this before you can do that. It's stupid, but it's something you have to pay attention to. Okay.
Okay.
What do you think? Do you think this is going to be a one-on-one session?
I don't know.
So you've had no problem with the were you able to access your grades on Canvas?
Yes, I can see them.
Okay, and were you able to go back and see my comments on the graphs?
Yes.
Okay, and I forgot. Sorry, I had about 24 to grade. Did I say something about expanding the axes?
Yeah, for my y-axis.
Okay, that's basically what happened. Is your scale was too. I have to sit here and think. Your scale was too small.
Okay.
If you make the scale too small, you don't use the whole graph. And the reason you need to use the whole graph is it makes the measurements that much more accurate. It's something I have to teach. You know, honestly, you know how to do Excel now, right?
Yeah.
So if you know how to do Excel, then basically, you're never going to have to hand graph again.
Okay.
And I've been sitting here kind of tap dancing away. Do you know if you got this in the lab? Did you get this in the lab email?
I don't know, because I was just kind of I had it sitting up in the inbox, so I just refreshed it and it pulled right up.
The reason I'm asking is sometimes yeah. Okay. All right. No, I don't need that. I need this. And I have some angry people because people were not doing what I was asking. Somebody is not submitting things and okay. All right. Well, we'll just get ahead and get started. I don't want to waste your time any.
Okay.
Just let me do one thing.
Okay.
And the amazing thing is, Jordan, I'm going to get lots of panicked emails on Sunday about it. Okay. Where are you going to school, Jordan?
I'm going to USF in the fall.
Oh, good for you.
Yeah.
Good school.
I'm excited.
You've been at Hillsborough the whole time?
Yeah, this is the end of my second year. I usually go to like the Brandon or Plant City campus just because it's closer.
You live out in Riverview or somewhere like that?
Yeah, I live in Brandon.
Okay. By the way, don't that no, but when I just sent an email and said nobody's here, present company accepted. Okay, let's get started with this. All right.
Okay.
I'm going to give you a screenshot of the module first,
Okay.
or actually of the core of my email I just sent, and we're in. Okay.
Mhm.
All right, just to explain a few things that are going on. You probably don't even need me, because one of these two, Dr. Liu, has done a description of the experiment himself. So if you're not understanding what I'm saying today, try that first, then go back and do a re-recording of mine. Okay? Make
Okay.
sense?
Yeah.
This is the actual lab, I believe. And it looks, I saw this and I'm like, oh my God, this is like a research paper, because it's written that way. But in actuality, it's all good. This is how to do a graph on Excel. Okay. That's the pre-lab you needed to do. This is the worksheet. Now, the second video is the important one. You need to go through this. This is 4 minutes out of your life. The only thing you're watching this video for is to get the boiling point. Okay, Jordan? Okay. If you have the boiling point, what that does for you is you go down to this chart, and that will tell you what the substance is, and more importantly, what the heat of vaporization is. You're going to need that. Okay.
Okay.
So we're doing two separate experiments today. The first, and one of them, I was about to say first, but that may be an incorrect statement. One of them is going to involve the 2-point Clausius Clapion. The other is going to involve the straight Clausius Clapion equation. Okay.
Okay.
Let's go and see which one is which then. Okay, you're going to, basically, he's going to show you what the boiling point is. You are going to look at that chart, that atmospheric pressure there. That's right below where the video is. There is a picture of a barometer. You're going to use that to determine what the number of torr you have. So that's going to be the atmospheric pressure. From the table and the boiling points, you're going to get this number and the heat of vaporization. Okay. Okay, so that is literally everything you need to know from the first part. That is going to be the 2-point equation. Fair enough?
Yeah.
Okay, so the second half of this, basically, we're giving you all the information. Okay, Jordan? What you're going to have to do is you're going to have to take the vapor pressure, take the Ln, and plug it into there. Okay? Fair enough? You're going to have to take the temperature and take 1 divided by the temperature in Kelvin and put it here. Okay. Then you are going to use, this is your y-axis, this is your x-axis, and you're going to plot a graph.
Okay.
You are going to get the equation of the line with that graph. Okay, Jordan? And when you get the equation of the line, that will give you the slope. Okay. Slope is equal to the negative delta heat of vaporization divided by R being 8.314. But you're going to have to change that into kilograms. When what you're going to do is you're going to be multiplying the slope by negative R, and that will give you an answer in joules. You have to convert that to kilojoules. And that's essentially what you're doing in this experiment. Okay.
Mhm.
Guys, I understand Gianna, and who's on their phone?
Me, Gabrielle Sosa. I'm on my
Right.
way to work, so I can't really be on the Zoom.
No problem, Gabriella. Just please don't do anything crazy like getting into an accident.
No, you're just on my Bluetooth. It's all good.
Okay, so I just was going through and telling Jordan about the experiment. Jordan, do you have a good understanding of what's going on?
Yeah, I'd say so. It doesn't seem too bad.
You please stick around. That is essentially what the PowerPoint is that I'm going to show in a few minutes.
Okay.
But please stick around to make sure that you got it down. All
Okay.
right.
This is recorded, right? So that I
Yes.
can actually watch your computer Zoom?
Yes, you can.
Okay, awesome.
It will be recorded. All right. Now, okay. I need to get out of here. We're going to go back to modules. And again, Jordan, I'm sorry to repeat this. You're going to go back to modules, go up to or scroll down to heat of vaporization. The first one, I believe, is a video. One of these two is a video from Dr. Liu, basically doing the same thing I'm doing right now. So if you're not understanding what I'm saying, please view that. It may enlighten you. The next thing is the boiling point experiment, and it gives you this big, it almost looks like a research treatise the way it's written. Okay? It almost looks like a research treatise. It gives you a video on how to do an Excel graph. Please, guys, learn how to do this. It's a whole lot easier. If you did hand graph one of the examples and you did Excel, you already know how much easier Excel is than hand graphing. Please just do Excel. Hi, Jennifer.
Hello.
How you doing?
I'm doing okay.
Okay, now, Jennifer, I'm just in the module. I've clicked on the third icon down, and that opens the lab report. You have the first video as on how to graph in Excel. The second one is the one you need to do. The whole reason you are viewing this video is basically to see what the boiling point of the liquid is. That is the whole reason you're viewing this. It goes through the entire experiment. It's 4 minutes long. It's 4 minutes out of your life. Down below that is a barometer. You have to measure the barometer. These numbers are in torr. So you have to read what the barometric pressure is. This is the barometric pressure of the atmosphere, which means that it is going to be equal to the pressure at boiling point. So you're going to have to relate the temperature of the boiling point with the temperature of the atmosphere. The chart right below, if you have the boiling point, you've identified the substance, and you've identified, more importantly for you, the heat of vaporization. Okay? That's the first part. We're going to be doing the 2-point Calcius Clapion for that one. The second part, you're going to have a whole series of vapor pressures versus temperatures in Kelvin for water. You have to convert the vapor pressures to the ln of P. In other words, in your calculator, just hit the ln button and type in these numbers. Whatever it reads, that's what the ln of P is. You have to convert the temperature to 1 over T. Hit 1 divided by, plug in these numbers. You will get these numbers. Now, what you're going to do is you're going to plot in XL, ln of P versus 1 over T. Remember, in Excel, the X, this is going to be your X axis. Your X axis gets put into the first column. So you're going to plug in all those values. You're going to get the graph. And then that's essentially the entire experiment right there. Okay, now I'm going to go into, I'm going to stop share for a second and plug in my PowerPoint, which will get in the calculations, okay? Everybody's seeing the PowerPoint at this point?
Yes.
Okay. Slideshow from current slide, yay. Okay, basically, we're all Floridians. We know about the liquid's ability to evolve into the atmosphere. Basically, that's what humidity is. That's why we're sweltering. It's because liquid water gets forced into the air because of its vapor pressure. Now, the equilibrium is affected by variables, temperature of the air around us, and the pressure of the atmosphere. Basically, the hotter the day, the more humidity we feel. Again, this is something that is making a whole lot of sense. Correct, guys? Correct?
Yes.
Okay, by definition, the temperature at which the vapor pressure of a liquid equals the external pressure is the boiling point. So therefore, when you're looking and you're seeing that liquid bubble and you're reading the temperature at that point is equal to the barometric pressure, which is in that barometer you're reading just below. Again, all making sense, guys? Questions? Okay, so when you're reaching the boiling point, what you have to understand is that all the energy is going into making the liquid into a gas. So the temperature doesn't go up. This is why the boiling point temperature stays the same. If you look, when he's doing the experiment, if you look at the very tip of the thermometer, what is happening is the liquid is evaporating. Then it's seeing a cool surface, the thermometer. It's condensing onto the thermometer, and eventually the water or the liquid builds up enough that it drips off. It's not going to go any higher until all the liquid is in the air and there's no more condensation. For this to happen, the temperature has to be high enough that the vapor pressure of the liquid is equal to atmospheric pressure. So we can basically relate that through something called the Clapion equation, where the ln of the vapor pressure is equal to negative the heat of vaporization divided by R times 1 over T plus the ln of B. Note, if I take the ln of Y to be my, ln of P to be my Y value and 1 over T to be my X, I have the equation of a line. My slope is negative delta heat of vaporization divided by R, and my y-intercept is the ln of B. Also, the other thing, guys, keep in mind, because a lot of you are in my lecture, one of the biggest errors I have is that people do not change R, which is in joules, to kilojoules, because delta H vape is in kilojoules, or you can change the kilojoules into joules. It doesn't matter which one you do, you will get the same number, but you have to convert one to the other. So we're going to get the we're going to get a straight line. The slope of that line is going to be minus delta H vape divided by R. If we measure 2 points, if we measure 2 temperatures or 2 pressures, we can determine what the second temperature or the second pressure is if we know delta H vape. Understand, all 3 of these equations are the same. You will get the same answer with any one of the 3 of these. It's just mathematical manipulation. So choose one and make sure you stick with it. So basically the experiment, we're going to shove some liquid into a test tube. We're going to fit a thermometer into a rubber cork. We're going to put it into a water bath and we're going to heat it slowly. We're going to watch a couple things. We're going to watch for the condensation at the very end of the thermometer, and we're going to watch for a steady temperature. Generally speaking, this is not perfect because you've got heat transfer from condensation to evaporation and back and forth. So generally speaking, if you're looking at this in the real world, the boiling point isn't going to be exact. You're going to have a range where the boiling point seems to stay pretty steady between a certain range of numbers. Then once you get beyond that, it shoots up incredibly. We're going to say that in my example, mine boiled between 61 and 69 degrees centigrade. If I look at that chart, I'm going to see that that boiling point range fits fairly nicely with methanol. So now I have the value of delta H because I'm reading right off of that graph. I have a temperature, average the range. So if the range is somewhere between 61 and 69, that's going to give me an average of 65. So that's the temperature I'm going to use. I now have a delta H and an R. We need something else, and the problem is going to give that to you. The problem is going to ask you something. What is the vapor pressure that methanol exerts at 65 degrees Celsius? So now I've got the boiling point. I've got the pressure that's associated with that boiling point. I have the second temperature. I have delta H and I have R. Plug them into the formula. Okay, this is a formula. Notice that whatever is on top in terms of the pressure is the first temperature that you record. So in this instance, I call P1 my atmospheric pressure, which is 760. That corresponds with the 338 in Kelvin of my boiling point. My delta H, when I looked it up in the table, was 35.3 kilojoules. I turned that into joules. So I got 35,300 joules. I keep the left term the same. I do this math out here. I end up with a negative 1.83. Notice, guys, I am not at this point multiplying both sides by 760. That is the wrong math because this is the ln of P2 divided by 760. It's not the ln of P2 subsequent number divided by 760. It's the number of P2 divided by 760. Take the log of that. To get rid of logs, you have to get rid of ln's, you have to raise that to the natural value of E raised to that power. I take e raised to the ln, that is 1. So if I raise both sides, e to this power, e to the ln goes away as 1, and I end up with P2 over 760. That is how we get rid of logs. I raise e to the negative 1.83 power. That comes out to be a real number. I just find the e to the x button on my calculator, press that, plug in negative 1.83. I end up with a value of 0.162. Now I can multiply by my 760 and I get 123. Because the 760 is in Tor, my answer is also in Tor. Anybody have any questions? Talk to me. We're good? Give me a hands up. Give me a thumbs up. Jennifer, you're not visible. Gianna, give me a thumbs up. Or hit the hand clap. Jennifer, good. Okay, but Jennifer, you need to visualize yourself. Thank you. Jordan, you're good. I just caught her just as she was drinking something. Okay. All right, that is 1/2 of the experiment. Okay, next. What we're going to do is we're going to have all of those pressures, those vapor pressures of water that are plotted against the temperature, or that are in a table against the temperatures. We have to change the pressures to LNP. We have to change the temperatures to Kelvin. Then we have to take 1 over Kelvin to get 1 over T. So we're plotting a graph. LNP is the Y, 1 over T is the X. So therefore, when you're doing Excel, 1 over T is going to go in the first column. LNP is going to go in the second column. I go out, I do my graph. I end up with my equation of a line. Y is equal to negative 4636.7x plus 19.467. I've got my slope. M is equal to negative delta H over R. I multiply my slope by negative R. That gives me delta H. Understand, slopes are always going to be negative. I'm multiplying by a negative R. Delta H will always be a positive number. I get it in joules. All I have to do is divide by 1,000, 1 kilojoule over 1,000 joules. I get my results in kilojoules per mole. That's all I have, guys. It's a fairly straightforward laboratory that really the calculations aren't too hard beyond the math part is the hardest part of this for the 2-point. Do I have any questions, guys?
I have a question about the quiz due tonight. Where is that information?
Quiz due tonight.
That's like on the quiz found.
Quiz due tonight. You got to be more specific. What do you mean by quiz due tonight?
Graphing quiz tonight for our class.
That's actually due at 2.
Graphing quiz was due on Sunday at midnight. Graphing lab was done last week, right?
No,
Yes,
are we
but there's
talking
a
about the
quiz
graphing
due tonight.
quiz?
Yes.
Yes.
Yeah. That's due
graphing-
today at 2.
The graphing quiz was due Sunday at midnight.
It says today.
It does?
Yeah, it says today. I haven't done it yet. It says
Okay.
today. But where is that like information at?
You
Or
find
is
it in
that
2
just like, are you
places.
going based off of our Zoom?
Okay, screen sharing is stopped. Okay, two places. If you go into the modules, under graphing, remember everything, you can access everything in modules. You're in graphing, graphing quiz. Are we good with that? This is Gianna asking.
No, it was the phone. I'm not sure who that is.
I'm sorry.
Gabrielle.
Gabrielle.
Me and Gabrielle.
Sorry, I'm sorry. I've given you till June
Yeah, that was me.
1st. Understand this. Most assignments we're doing today, we're doing heat of vaporization. On Thursday, we are doing colligative properties. Okay? We're doing both of those labs this week. Both of them are due Sunday at midnight. Okay? I will, if you do the graphic quiz, obviously, since I put it at June 1st, I will obviously accept it and re-up your grade. Okay, Gabrielle? Gabrielle?
Yes, I said okay, thank you.
Sorry, I did not hear you.
Oh, okay.
Any other questions, Gabrielle?
Nope, that's it. Thank you.
Okay, Jordan, I'm done with you. I would like to speak to Gianna and Jennifer, independent of you, if you would not mind.
So do you want like one of us to come back or?
No, just you're fine. Gianna and Jennifer, you were fine. I just don't need to involve any more people. So Jordan, that's all I'm saying today, unless you have any questions.
No, I don't.
Okay, I will see you on Thursday then, or I'll see you later on today.
Okay.
Bye.
Bye.
Gianna, I think I
Is it
will
okay
talk with you
for-
first. Okay?
Okay. Is it okay
You
for
sent-
me to leave as well?
I'm sorry?
Is it okay for me to leave as well? Did you cover
It's going to be
everything?
quick, Gianna. You sent me an email regarding
The
participation.
All right, yeah, that too.
I have not had a chance to read the email yet. I just happened to see that you had a subject of participation, and I imagine what you're doing is you're asking me questions as to why you got only half the points.
Yes.
That's because I did not see any response for you from the original scavenger hunt.
Oh, okay. All right, makes sense.
All right. So that's why you got half the points.
Got it.
Okay. That's all I have for you, Gianna.
Okay.
Thank you.
Thank you.
Jennifer, I'm sorry if the tone of my email was a bit harsh, but when I get done with class, when I'm going to answer emails, I'm sorry, hold on one second, Jennifer. Vanessa, are you here for a reason? Vanessa,
Yes.
are you here for a reason?
What do you mean if I'm here for a reason?
I made an announcement that I'm done giving the lecture in the lab. I wanted to speak with two people privately. I didn't see that you were still here. So I'm asking, is there some reason you're still here?
Oh no, I'm sorry.
Okay. I will see you later then, Vanessa, okay? Unless you have a
See you later.
question about something.
No questions. I'll see you later.
Okay, I'll see you later. Okay, Jennifer,
Yes.
I need you to look and see things that are already in the course. You asked me a question about practice tests, right? Jennifer?
The review, yeah.
Okay. Now, if you go to the course, right now, are you seeing the screen?
Yeah.
Go to modules. Go down. Test material. I've got thinking questions for test 1, answers to problems from test 1. Practice test 1 problems. That's all here, Jennifer.
I was looking at files. That's why I didn't go to modules.
Jennifer?
But afterwards,
Jennifer, I keep on telling you, look at the modules.
okay.
All right? Because everything is organized there. As a matter of fact, I probably should take the files and make them hidden to you guys, because you get yourselves in trouble when you look at the files. Now, do you know where they're at, Jennifer?
If I know what, I'm sorry.
Do you know where the information is?
Yeah.
All right. Now, I need you to at least look through things first. Look through the modules. Then email me if you can't find something.
Okay.
All right. I appreciate that. Thank you very much, Jennifer.
You're welcome. I have a question about this lab.
Okay.
So I did print out that worksheet that was provided in the reading. Do you just want us to submit the graph itself for the report with
Okay,
like the
let's-
points?
I thought it was pretty self-explanatory, but let's go in and see what it needs. Okay. All right. Okay. Here, are you seeing the screen right now, Jennifer?
Yeah.
You're seeing the report sheet heat of vaporization.
Yeah.
Okay. I am going to I got to get into it this way. What is going on here? Thank you for asking the question, because I am not seeing.
Usually it has no content, so I don't know what to actually look for or do specifically unless you say it during the lecture for lab.
God. I'm sorry. I'm sorry, Jennifer. I have to create something.
Okay.
I was I'm flabbergasted. I'm sorry. I'm okay. Start assignment. Okay. This is basically what you're doing. Okay, Jennifer. All right. All right. Okay. So what you are doing is you are printing out the boiling point heat of vaporization is the actual lab report. You've
Yeah.
seen this, right, Jennifer?
Yeah, I printed out the worksheet.
Okay, great. So at the end of the worksheet, you're going to have to fill out a couple tables. you're going to have to do this table, ln of P versus 1 over T. And okay, that's where it is. You see this where it says worksheet, Jennifer?
Yes,
Print that out,
I did.
and you're going to, this is where you're going to record all your data.
That's based off the video that we're gonna watch. That's
The
provided
only
down
thing
there.
you're going to need, Jennifer, is the boiling point. Okay, that's the only thing you're watching the video. Don't worry about this thing. You need the boiling point. You need to change the boiling point to K. Then you are going to look at the barometer to get the pressure.
Okay.
All right. So that's what goes in there. Now, from the table, right after the barometer, there is a table. You're going to look, you're going to find the boiling point. You're going to identify what the substance is from the boiling point, and you're going to plug in the heat of vaporization. Okay, Jennifer?
Okay. That's into the formula, correct?
I'm sorry?
Into the formula?
No, you're just reading it. Say the boiling point was 65. You're going to look and say, oh, I'm going to look at this table. I'm going to see, okay, my boiling point was 65. My substance is methanol. My heat of vaporization is 35.3 kilojoules per mole.
Okay.
And I am going to plug that into my unknown liquid is, put that there. My heat of vaporization is here. Now, it asks you in the next statement, the vapor pressure of the unknown liquid is 295 K. It's asking you a question. What is the vapor pressure at 295 K? You just determined that at your temperature of boiling at K, that is equal to the barometric pressure. Now this is saying, okay, we now have delta H vape, R is a constant. We have everything we need to do to determine what that vapor pressure is at 295. So in the calculated data, you are going to plug in, your equation, ln of P2 over P1 is equal to negative delta H vape over R times 1 over T, or times 1 over T2 minus 1 over T1. You know T2 because T2 is this. T1 is this.
There, okay.
P1 is the barometric pressure.
You're trying to find P2.
You're trying to find
Okay.
P2, not T2. You're trying to find
P2.
P pressure. Okay, we're good with that, Jennifer?
Yeah.
Okay. Next thing you're going to do, you're going to have this table. Complete it. Then you are going to graph this versus this. You are going to have a slope. You're going to read the slope. Hopefully you're going to do it on Excel because it's a lot easier that way. You're going to read what the slope is. Then you're going to take the slope, multiply it by negative R. That will be your delta H, convert it to kilojoules per mole. Then you have 3 post-lab questions.
And we would have
Okay.
to submit this whole sheet into you for the report?
You are going to take pictures of
Okay.
this sheet,
The Excel one.
and this sheet. Okay, just those 3 pictures. And you are going to submit it in that You're going to take those. I'm in student view now. You're going to go there and you are going to go to the module. You are going to go to the heat of vaporization laboratory and hit start assignment. All the start assignment is going to be, you're going to hit the upload file, choose file, and from wherever you've stored it, you'll be able to upload the files. Okay, Jennifer?
Okay.
That makes sense?
Yeah.
So that's basically what you have to do to get the 90 points here.
Okay.
Fair enough?
Yeah.
Okay. Any other questions, Jennifer?
For that chart, I just want to make sure, like the L and P and the 1/T, we just use the information given, plug it into the equation to find the X values and the Y values.
Yes.
Okay. Just wanted to
All
make
you're doing, I'll go back to modules, leave. I'm going to go back into the
Okay.
boiling point and heat of vaporization. You are going to go down here in it's under the worksheet. You're going to hit the worksheet. And the second page of the worksheet has the vapor pressure versus the temperature. Turn the vapor pressure into L and a P, turn the temperature into 1/T. You are going to have two columns here. Okay, Jennifer?
So let's say example 1, you do ln of 9.2, and that's the first little square.
Yes.
And then the second one would be 1/283, which is the Kelvin temperature.
Yes.
Okay, makes sense.
Okay, so the difficult thing is when you're doing the Excel graph, the 1/T goes in the first column. L and a P goes in the second column.
Okay.
Opposite from where they are, what they are here, okay?
And you recommend how many significant digits? So for vapor pressure, depending on how many they have.
Yes. However many this has, that's how many this is going to have.
Okay.
For temperature, it's going to be easy. They're all going to have 3.
Okay. All right. And I did email you. I don't know if you got to it, but if you could set up like a Zoom meeting tomorrow, or if you do have available, to kind of review some of the math portion covered in lecture, just like a few questions if you are to.
Okay, it's about 9 o'clock now. What I'm going to do, Jennifer, I am going to hit stop share. I am going to